Need for multiplexing chapter, third chapter, multiplexing. Multiplexing. What is the need for multiplexing? uh, multiplexing need for the terms of multiplexing is mixing is one kind of techniques for combining the multiplexing multiple of analog signals and as well as the digital multiple of analog as well as the digital into one signal over a channel is called as the multiplexing. Nowadays we are using the multiplexing techniques over combining the multiple of signals is called as multiplexing. Multiplexing are two types to multiplex many signals like analog signal. Basically it is a continuous signal. Digital signal into a digital signal is sending the information is binary information. That is the binary information we have to send. Binary is digital is in the form of 1 and zeros. 1 and zeros. Digital signal is 1 and zeros, and it is multiplexing is applicable for this techniques is applicable telecommunication as well as computer networks. Many ways we have to using the multiplexing applicable at telecommunication as well as a computer networks. And कोणी बातें कर मत वॉइस रिकॉर्ड कर रहा many signals techniques applicable for telecommunication as well as computer networks. Networks is two or more devices connected through a LAN network to sharing the information. That's why this is the many signals or multiple of users can add it to the internet. That added to the internet is applicable for multiplexing internet through using the sharing of the information. For instance, in telecommunication and also telecommunications and also we are using for telecommunication telecommunications many of the signals used for telecommunication purpose. Telecommunications and one of its carrier is multiplex telecommunication as well as the computer networks. Computer networks and to add the networks one or more signals to communicate through the sharing of the information. For instance, in telecommunications, one cable is used for carrying different telephone calls. One cable is used to carry the different telephone calls, and two or more signals to add it to a single call for landline phone and voice signals and data signals. For instance, in telecommunication, one cable is used for carrying different telephone calls. In the year of 1870, the multiplexing techniques is invented first in telegraphy. It is extremely used in communication system. In 1980s, multiplexing techniques is invented the first in telegraphy, and at present it is extremely used in communication system. Now the scientist George von Square was recognized the growth of the multiplexing. The scientist George von Square was recognized the growth of multiplexing in telephony. Recognized the growth of multiplexing in telephony system in the year of 1910. The signal which is multiplexed will be transmitted over a cable. The signals which is multiplexed will be transmitted over a cable or channel. Cable is a physical component to multiplexing, adding the signals and transmitted through a channel and through a transmitting end. The long distance to transmit communicating the analog signal and also digital signal channels are separated the channel into numerous logic channels and separate the channels, separating the signal at the end of the receiver. Two individual signals are separated and individual receivers are collected by the different users. What the frequency bands are utilized, those who are frequencies bands to sharing the frequency of different users at the transmitting end and receiving end. The logical channels, then we have to multiplex. Multi means multiple, and mixing of the signal is called as a multiplex. And then multiplex, and multiplex is mixing of multiplexing is the mixing of the signal. Mux and multiplexing can be defined as it is a way of transmitting various signals over a media and a single line. Transmitting various signals over a medium and a single line to using the common cables that we have to using this transmitting various signals over a media a single line that added to a single line, sending the multiplexing and media are a single line. Then we are next multiplexing. The kind of multiplexing merges a number of kind of multiplexing and merges number of the signals at different speeds, like as a low speed of the signal. Kind of multiplexes merges number of low speed of the signals to send over speed of the signals to send over and only high speed link. Low speed signals and low frequency signals like a voice signals or multiplex are merging. Merging means added or two more signals send over and a only high speed link. The high speed data links like OFC cables and wireless signals, or it is used to transmit a medium It is used to transmit a medium as well as its link. To transmitting a medium and a cable, it is used to transmit a medium as well as its link with the number of devices. Number of devices means you can use the printers, speakers, and scanners, and multiple of users, multiple of printers, multiple of systems can sharing the data through a cable is using for the number of devices. It is used to transmit a medium as well as its link with the number of devices. It provides both privacy and efficiency. It provides both privacy and efficiency. The entire process can be done by using the device, namely MUX. In nowadays OFC system installation department and OFC department multiplexes most of the designing of the MUX. The entire process, the entire process can be done by using devices. Various devices is called as the MUX multiplexer. And main function of this device is to the main function of these devices is to unity and endpoint lines for endpoints and n lines or n users. Endpoint lines for generating n inputs, lines for generating a single output line. Number of inputs, and multiplex acting as a many inputs and get the single output is called as the many input lines for generating a single output line. Thus MUX has many inputs. MUXes are many inputs and signal output. MUX has many inputs and signal output. At the receiving end, we have to use the demux. A device is called demux. Our name is demultiplexer. Demultiplexer or demux. The device and the equipment will be there to designing the demultiplexer is to receiving end. This will be a receiving end. This can be used for the receiving end at the receiver to using the multiplex. Uses for this multiplex and multiplexes and used for this devices demultiplex and demultiplex and demultiplex and demultiplexes. Demultiplexer is used to at the receiving end. At the receiving end, we have to use the demultiplexes. Device is called demux and demultiplexer used at the receiving end. The needed at the receiving, which needs the devices. The divide and number of signals are multiplex, and at the receiving ends divide the signal into its component signals, divided into multiplex and divided into multiplex. Divided into multiplex demultiplexer, and the device is called demultiplexer is used where we have to use this demultiplexer used at the receiving end. The divide the signal into its component So it has a single input and a number of outputs, means it is only one input and a number of outputs. We are getting the number of outputs at the receiving end. At the receiving end, the demultiplexer used at the receiving end. Demultiplexer is used at the receiving end. Demultiplexer. The device single into its component signal, so that signals input and the number of outputs, single input and many outputs at the demultiplexer. As shown, this is the basically we have to see that next slides is going to be a multiple of low data rate signal, multiple of low data rate signals are multiplexed over a single high data rate link. There is a single link and the demultiplexer at the other end, means multiple low data rate signals, multiple of low data rate signals, and then we have to transmitted a multiple low data rate signal at a low speed. Some data may be a low speed, some data may be high speed, and analog signal will be low, and different voices, different speeds, and different coming from the different sounds. Multiple low data rate signal are multiplexed over a single high data rate through a single over a single high data rate link, then demultiplexed at the other end. Here we have to n inputs. We have to get this, see this number of input, see that number of inputs. We have to see that here number of inputs, number of inputs, number of inputs, number of inputs, and number of inputs. Here this slides will be showing here n inputs, arrow mark of here the input, number of inputs, n input signals, and multiplexed here, frequencies are multiplexed, and going to be a common channel. This common channel will be sharing the information, and we have to get the data here collected, and individual data will be separated and demultiplexed at the other end. This will be get the demultiplexed at the other end. This is the multiple of data rate signals are multiplex them over a single and get high data rate link. That is the different speed we have to the high speed to link up the signal data, and radio signals are linked, and then demultiplexed at the other end. Then next slides of this multiplexer will be going to be shown here. Many ways we have to using this multiplex applications of multiplexing. The applications of multiplexing include the following: analog broadcasting the signal, and digital broadcasting, analog broadcasting and digital broadcasting, analog broadcasting and digital broadcasting, and broadcasting of the high frequency signals, broadcasting analog and digital signal, broadcasting of digital signal or broadcasting with high frequencies, different bands we have to multiplex and sharing those frequency at the receiving end at the using analog and digital broadcasting signal. Next applications will be going to be telephony system. Telephony system is using for the voice signal. Tele means far and phony is the distant speech, and tele and far to sharing the voice signals through a landline phone is called as the telephony. Next point is going to be a video processing. Processing means taking the data from one point, processing of a system, give some input and get the quality of the voice signal. We have to get the receiving end by using the voice as well as images. That image processing, the lot of techniques are there to processing the signal messages is the video processing. Video is the image signal and voice signals. Next application will be provided by multiplexing is telegraph. Telegraph means tele and far and graphics, and this is also different data we had to share by sending the information. Next we have to go to the types of multiplexing. In this chapter we have the various multiplexes or their types of multiplexing. In our syllabus of multiplexing, types of multiplexing techniques, multiplexing and the techniques are mainly used in communication. These are classified into three types. One is frequency division multiplexing. And frequency division multiplexing and FDM. Next is the wavelength division multiplexing. Wavelength is multiplexing wavelength, and also is a time division multiplexing. These all are the three types of multiplexings are used in digital communications. Multiplexing techniques are mainly used in communication purpose. Only for multiplexing used for the communication purpose. These are classified into three types. These are classified into three types. First one is again the FDM, TDM, and wavelength. In your category we have to using for frequency division multiplexing and time division multiplexing. Then we have to using this advantages of multiplex. Advantages of multiplexes is advantages to reduces the number of wires, means linking the information 10 members we are using the 10 wires, and 13 members 30 wires, goes on increasing the wires, and multiplex linking the data from one source to the destination. It is reduces the number of wires, and to share the information, and linking and a bunch of wires to get that source to the destination end. Second advantage is to multiplex, and second point for the advantage of multiplex, it reduces the circuit complexity and cost. This multiplexer nowadays we are using telephony system to overall complexity and designing of the simplicity to utilize the users. That's why we are using it. Is reduces the circuit complexity and cost. Cost is also another factor for the taking the manufacturing the useful for the customers, and useful the low cost we have to quality of the designing, and also low cost to maintain it. It reduces the circuit complexity and cost. Third point Third point, we can implement many combination of circuits using mux. Multiplexes, we can implement many combinations. We can implement many combination circuits using mux multiplexes. You can implement many combination circuits using mux multiplexes. Many means two or more signals you have to maintain, and you can implement many signals circuit using mux. Many signals are used to mux, and it is needed to be implemented many combination of circuits using mux. And fifth point, it will be goes to the advantages of this. It does not needed to k maps and also simplifications, and it does not needed for k maps and simplifications. It does not mean to that utilization of this advantages of this multiplex. First, we have to reduce the number of wires and the complexity and cost, and implemented many combination of circuit using mux, and it is needed to, it does not required to maintain the k maps and simplifications. Cannot maintain the simplifications. That are the advantages of it. Reduces the number of wires. Number of wires are bunch of wires are reduces, and quality of voices, quality of images, quality of pictures can be sent through the different process techniques. It reduces the circuit complexity. It reduces the circuit complexity and cost. Third point, we can implement many combination circuit using mux. It does not need to be k maps for simplifications. And next, disadvantages over the multiplexers. Multiplexers is disadvantages for adding some delays in switching ports, and computer networks switches. Switching of many techniques are there. One is PSTN public switch telephone network to switches the signals to transmitting the signal, and delays, any delays added the delays in the switching ports. And port and then LAN network, local area network, and LAN WAN network, wide area networks, added delays in the switching ports. And also using the computer terminology, local area network, LAN network, and WAN network, wide area network, added delays means delay and ports, LAN network, different networks topologies to transmitting the signals, like a switching ports. Switching ports means switches the ports means we are using the bus topology and ring topology, and bus topology, ring topology, tree topology, bridges. In this way to switching ports to transmitting the information. That's why they added some delay. A delay means we have to connecting of one or two devices, or connecting from one wire to another wire, to communicating the longer distance or shorter distance. There is a technical support to some delays are required for a public switch telephone network, PSTN, and also wireless signal. PSTN is public switch network, and if 8 members or 8 users to different nodes, we are transmitting the switching various switches and take over the signal from one point to another point. Take over the information one point to another point is called as the added delays in the switching ports. And second point will be go to the disadvantage of multiplexing. Second point is limitations Limitations on which ports can be used simultaneously. Some limitations are there, and some limitations on which ports, different ports, and ports means one input device is one point and connected to the output of another point to sharing the information, that is called as the ports. So many devices are connected in the LAN or WAN network. Some limitations are required. Limitations on which ports can be used simultaneously, one by one. Simultaneously the data can be transmitted. Simultaneously we have to sending the information. Limits on which ports can be used to simultaneously. Third point it will be goes to the third point, added firmware added to the firmware complexity to handle switching ports. Added added to this added firmware complexity to handle the switching ports, and firmwares and various computer terminologies to handle the switches, to sharing the quality of voices, quality of images. Sometimes it may be poor quality of the signals we are transmitting, and to improvement of this signal image quality and voice quality. Then fourth point, the disadvantages of this disadvantages. Another point is, fourth point will be go to this multiplexing is added delays in the input and output signal. Input signal and output signals propagating through the multiplexer. Multiple and plexer means multiplexing. Added delays means one point to another point. Added delays in the input and output signals. Propagating means propagate and some delay time lagging or leading the time or lagging the time between the devices to sending the one by one signal to receive the multiplexer. To the multiplexer many signals, some input to the output, leading or lagging circuits. By delays, it can be delays to minimizing the noises and delay the circuit, delay the points. That's why it is added some delay circuits in the input and IO signals, means input signal and output signals propagating through the multiplexers, and this is the way we have to multiplex in the input and output. Fifth point, it will be goes to the input, extra data is extra will be there, and then we have to go to the input and output ports. Required extra input ports and extra output ports required to control the multiplexer. Extra IO devices. Extra means input and output ports are required to control the multiplexers. This is the way to input ports in many internal computer ports. Extra ports are added to the PCB. To additional devices are connected according to the requirements, according to the user's requirement, according to the system capabilities, and according to the system speed and system performance. These all are the way we have to additional input port and output ports are required to control multiplexers, and this is the way we have to using the disadvantage of adding delays in the switching ports, added to the switch ports, and added the delays in the switching ports, and limitations on the input ports and output ports and various devices. Input port, multiplexer, decoder, encoders, all communication system. We are using the various equipment, transmitting equipments and receiving equipments, repeaters. All those things are used to add delays in the switching ports and delay switch is that one point to the another point, one circuit to the another circuit, to exchanging the information and transmitting the information. That's why it is called as the added delays in switching ports. And second point is limitations on which ports are used in simultaneously and one by one. Sequentially it will be ports are transmitting one by one, that is called as simultaneously transmitting. The limitations on which ports can be used to simultaneously transmit the signals. And added to the firmware and complexity to handle the switching ports. And added to the delays in the added to the delays delay added to the delay added to the delays in the input and output signals propagating through the multiplexers and the extra inputs. These all are the way we have to using the multiplexing, requirements of multiplexing. To using the multiplexers are using for the many multiplexers. We had a long distance to communicating the signals. And multiplex digital communication, most useful topic, most useful for the users is multiplexing techniques. This is the basically we have to log various instruments, transmitter and receivers, and types of multiplexing and disadvantages. And see this various points are gathered to explanation and advantages. Multiplex in digital electronics. Digital electronics is also useful for digital information to calculating given to the sequence of data and counters and decoders, counters and synchronous counters, multiplexers, encoder. All those signals are used to maintain this process. K-maps in digital electronics to simplify the calculation of the digital in the networks, circuit networks, and this is the basic multiplexers are needed in digital communication system, digital communication network, digital communication process. And added to this disadvantages and advantages and many types. And then next we have to go to the next types of multiplexers, FDM, TDM, and two topics are there in FDM and TDM. And how to multiplex, how to frequency spectrums are calculated, and how to uses the multiplex in the frequency signals. And time division multiplexer is the times are divided. Frequency division means frequencies are division to multiplex by using these techniques. And time division multiplexing, and it is here time slots. We have to divided the time signals to dividing the time slots, time division multiplexing, frequency division multiplexing and time division multiplexing. Frequency division multiplexing, time division multiplexing, FDM and TDM. Types of multiplexing techniques. Multiplexing techniques are mainly used in communication. This is classified into three types: frequency division and time division multiplexing, and wavelength division multiplexing. Wavelength means wavelength. We are divided into wavelength by different optics waves. Optical fiber communication we have to use it for the wavelength division multiplexing, and the frequency division multiplexing, time division multiplexing. This is the way we have to multiplexes. Multiplexing, need for multiplexing, need for multiplex, need for multiplex, need for multiplexing. This as FDM used in telephony system. Frequency division multiplexed in telephony system, and time division multiplexed in also used for in telephony system. How to use this next topic we have to study the uses in the telephone system. Multiplex, added delays, and advantages and disadvantages of this signal. Multiplex mixing of one kind of techniques. We have to see that multiplexing is mixing one kind of techniques, is combining of adding multiple signals like analog signals as well as the digital signal into a signal over a channel. This technique is applicable in telecommunication as well as computer. Most of the computer devices, security purpose and sending the data, non-security for banking sectors. Security purpose banking sectors are needed, and any other private banks. The computer network security is more useful for this networks, and telecommunications is one cable is used for carrying different telephone calls. Telephone calls means call and voice signals, speeches, and many in previous stages. Multiplexing techniques invented first in telegraphy. Graphically means bits-wise, and bits-wise. Tele means telegraph, and at present it is extensively used in communication. Okay, this is the way we have to multiplex the signal. Multiplex. Can basically these are the marks in this. Most of the multiplex matches the in digital electronics equipment. Digital electronics, it is used for in digital electronics, and also we have to implemented mux and demux, high speed of the data in a lesser time to recover the whole data in lesser time, to saving the times and more efficiently utilize your information, to sharing with a less time to gathering the information. That's why it is used for many multiplexes. Multiplexes are needed to mux, and this is your basically block diagram to link the data in number of n inputs and combining them, and we have to get this combining them added serially, sequentially, one by one. We have to add the data and collecting at the receiving end, and individually by separating the data we have to collect them. That's why it is using for the multiplex. Most of the needed in our telecommunication system. This These are the most of the telephony system, many cables and analog signals broadcasting. These are the way satellite communications and submarine and digital broadcasting. Submarine, those are video conferences, telegraph, video conference, submarine, and in military purpose and also security purpose. These are the mainly we have to multiplex.